Alrighty then. So all the shiny happy people that will be here are here. So class, Miss Becker. See, look, I love the excitement right there. Okay, integration. This one's example 5, but again, it's actually not in your packet. So from 1 to 3 of 3. So bless you. All right, so these are always, I do my integration. So, or antiderivative. What is the antiderivative of 3? Huh? 3x.
Only
Antiderivative or integration. Integration. So I'm going to integrate that. So that's going to be from 3x. Now, the way we write this, with my bounds, okay, and it's from 1 to 3. Now we're going to evaluate this. So it's going to be 3 times 3. Okay, so it's top minus the bottom. So that's going to be a 3 times 1.
1.
Is stapler? I have no clue where it is. Someone stole it.
1. Oh,
yeah, so it's going to be 9, which is, so there we go. That's going to be 6. That's not too hard, right? Okay, so I am going to try and make it a little bit more complicated, but that is the basis. And I wanted to try and make sure you guys understand it's always going to be the top minus the bottom. And I was doing a bunch of these yesterday, so now you guys could actually understand why or what it came from. So the next one is 2 to 6. You're going to see stuff like this all the time, and I need to understand what is implied here. Implied. It is 1. Very good. It is 1, right? It is 1. So when I do the math, that's going to end up becoming just x, 1x, right? From 2 to 6. Right, Anthony?
Oh, wait.
Antiderivatives. There's 1 right there, right?
Yeah.
So, okay, yeah. All right, so let's go ahead and do it. Top minus bottom. So that's going to be 6 minus 2. ¿Está muy fácil? Sí, sí, es muy, muy fácil. -3 to 4. All right, so let's go with this. So what do we get here? This is going to give me
That's -2x.
-2x from
Which would equal -2.
2 times 4 minus parentheses. Okay, so now I'm going to double parentheses this. So I usually like bracketing, but for some reason you guys don't like brackets. I just don't like using parenthesis after parenthesis because I break them up into parentheses and brackets. They're the same. They mean the same thing. It's just you see differently. So negative 8 minus 6, which is negative 14. Now, there's a reason why I pointed out the thing with the parentheses. Why do you think that is? And one of the biggest problems people make, it's not in the integration, it's not with the calculus, it's with the negative sign. Just signs, that's it. So simple little bitty mistakes is where a lot of people actually struggle with because, yeah, they're kind of a pain. All right, next one. So this is going to be example 6. And it is from 0 to 3. All right, so for those few people that are paying attention and taking stuff down and not just ignoring everything, the parentheses around the function is important because that you have to be careful with, especially when you're writing on the AP, because otherwise it would only imply that your dx is this. It's kind of dumb. It really is. It is archaic where people would have to get like pretty nitpicky to pull out something that's incorrect from there. And it's, yeah.
So you always have to put parentheses though?
Around your function.
Okay.
So I'm recommending that. So it's not always there, but it's implied. So let's go ahead and when we integrate each term individually. So as I integrate each term individually, this is going to become minus 8x. Very good. From 0 to 3. All right, so top minus bottom. So that's going to be 3 squared over 2 minus 8 times 3. Now, on the which side?
Left side.
Left side? Put your both hands up, please. Put both hands, stick. Like,
Wait,
at me.
Wait,
At me, at me.
I did it wrong. I did the math wrong. I did the math wrong. I know my right to left.
Oh, you do?
I did my math wrong.
Okay.
Yeah, I did the smallest minus.
You did, oh, you did bottom minus top?
Yeah.
Oh, okay. But you did see it, though. Okay,
Yeah,
so all this is going to end up becoming 0. And this right here is going to be 9 times 3 is 27. 27 over 2 is going to be 13.5. Minus 24. And then minus all that 0. Which gives me a grand total of...
Or negative 10.
10.5? Yeah.
Yeah. 5. Even though I did it wrong.
Even though you did it wrong.
Yeah.
It's still fine. And last one is going to be the calculator one. Here, I'll write it over here for you. From 1/2 to 4. All right, scratch pad over here, especially for those people that never actually use their calculator. Okay, doing this is actually super important because learning how to use a calculator is part of this class. A calculator normally does not include your phone. Normally does not. It usually includes the calculator. Does said person have calculator? Okay. Can said person grab calculator?
I don't even remember my number.
48. Does Victor have his? Okay. Does Blade have his? I know Miss Becker does not. Did you ever get yours back? So someone stole yours, and you stole theirs, but you can't get it back. It's right there now? Oh, hey, good job. All right, so we're trying to do this. Miss Karen, do you have yours? You want to borrow one of mine? All righty. All right, so this is going to be key, especially if you're taking notes on this, because these calculators are super amazing, awesome. They're so super. So, see this delete button? Right below the delete button, there is a book, which is the catalog, and right to the left of that is the button we're looking for. Now, we're trying to do what type of problem? Integration, right? So, but look specifically at what I have. So there is for all these things, there are little templates for each one of these. Okay, especially if you're using E on your calculator, do not use the letter E. You have to use the number E, which is over here on the left, next to the LN.
Wait, what is doing the letter E?
What does that say, E? E says E? Yeah,
No,
it's a vowel.
What happens if you use the E? That's not there.
Then that's not a number. It's like replacing pi with a PIE.
Okay.
It's not the same thing. See what I did there? See what I did there? The number pi.
Wait, could you also use the E that's with the pi? Because there's E in the alphabet.
Yes, that's the one that you want.
And if you also use the pie that has the E?
Yes, that little it brings up a little table like this, right?
Yeah.
Yeah. So you could use that. Just don't use the letter E.
Okay.
Good. Because otherwise you'd be using like blueberry pie when you should be using, the Greek pie. Anyway, it's right here. Integration, definite integral with bounds. And so I have to identify what it is. So this one starts with 1/2. And it goes to 4. And it was ln of x. And I have to tell it what variable I am integrating for. That's important. What variable I'm integrating for. So that's going to be my x. Hit enter. Bam. ¿Está muy fácil? Sí, sí. Es muy, muy fácil.
I thought it was fraction. Yeah.
Okay, now hit control enter. There you go. Right? All right, so I know everyone's good now, so everyone's going to make sure they like, share, and subscribe. Hit the
What's called the antiderivative of ln?
antiderivative of ln.
Yeah.
Oh, that's the regular one. Without the.
No bounds.
I mean, that doesn't really like.
Yeah, it's not something that we're going to do right now. That's going to be something that comes up a lot later. When we actually go into more of these.
Be in our problem.
Not today. But that's why we're showing the calculator on this. When we'll actually go over, kind of like when we went through arcs. Yeah, inverse, sine, cosine, all those.
Yeah.
And I just gave you a table and I said, hey, this is this. It's those type of things.
Okay. So
All right.
we're supposed to memorize it?
Yeah, those are ones. And if you guys, anyone still have your flashcards?
Yeah.
It's in there. Highly recommend it. All right, again, like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my merch store.